Hello and welcome to Thailand on a beautiful blue sky and puffy cloud day. And it is hot. It's the middle of June. When's it going to start cooling down? I've been doing a lot of drone flying, which takes a lot of editing time. So you'll be able to see some of that coming up. But today I have an unusual project. It's a 3D CAD 3D printing project for a friend of mine. And as a side effect, I want to show you this. I've been using a little tripod and my phone to give you a view of what I'm working on, but I thought I would go for a vertical view. So I designed and printed this. My phone slides into it from the side, and it's on this articulating arm, which used to be a lamp like that one, but now it's a custom mount for this. And since I think of it as my satellite view of the desk, I had to put the SpaceX logo in there. So let me get this set up and we'll see if it works any better than the old tripod method. Okay, so here's the thing that I need to reproduce in CAD and then print. It's fairly straightforward and it fits nicely in the print volume of my printer, but the trickiest part is going to be the accuracy of all of these little tabs. I don't know, I gotta get more light on the subject. See all these little tabs along here? I have to replicate them exactly because, as you can see, it's been attempted repair and it's cracked and it just doesn't really do the thing anymore, and it's not available from the manufacturer because what this does is it goes on to this. This is a 200 to 500 millimeter Nikon lens. I don't even know how this thing works, but I know it's an impressive piece of technology, and Patrick really wants this part to fit on. As you can see, with all these little clips and things, they fit in here. So the goal is you go like that, and then there's a very satisfying click and click, and it's on and it stays on, and then you do your photography. And then when you're done, the really ingenious thing is you actually turn it around. You find your starting place again somewhere and click. Then you put it in your travel case. So it saves you, this much traveling space. So this is the goal for today, is to reproduce this part as accurately as possible. But the key part is just right here. The dimension here and getting all these tabs just right. The rest of it is not as critical. I'd like to follow the same general shape, but whether I'm off a millimeter here or as it flares out a little bit, I'll try my best. But this is critical. But the cool thing is I can design this in Fusion 360 and print out 4 or 5 millimeters of the structure and then test it on here to see if it works and make an adjustment and test, adjust and test, because the critical bit is actually a very, very small part of the overall design. So let's get started. Okay, as I was analyzing the design, I noticed something very interesting. So I drew a horizontal and a vertical line. And if we look at the opposite sides of the vertical line, that's the same as that matches that hole matches that, and all the way across, this thing is vertically symmetrical. That helps us a lot. So we only have to design 1/2 of this and then let Fusion mirror it across this axis. But if you look at the horizontal line, that matches that slot matches that matches that, the little bump there matches that. It's also symmetrical about the x-axis. So all I have to do is design 1/4 of this and then flip it across the x-axis, then flip it across the y-axis, and we're done. Unfortunately, there are no more levels of symmetry because this corner here is unique to this, so I couldn't make a symmetrical axis along the 45-degree here. So really all I have to do is get the diameter perfect and then sketch these little nubbies and then flippy flippy flip, and we're good. So let's try that. So for the design process, I simply marked out where all of these tabs started and stopped, and then put that onto a circle, and then drew the lines at the angles, and then mirrored them across the x-axis, and then the whole thing across the y-axis. One thing I didn't realize immediately is there are actually 2 different levels that these tabs live on. One is right at the top of the surface, and one is slightly below. So as I went through the design, I made the tabs the ultimate thickness, and then I shortened them up individually, leaving them as the top tab or the bottom tab, as is required all the way around. Then I built up the outer ring and smoothed everything over. Okay, here's a test print with only one small edit for tolerance. It goes on here, push down, turn, and click. Oh, that's magnificent. It's not very strong right now because it doesn't have a lot of rigidity because of the design, but once the rest of the shell goes on, it should be good. So that is, I think, 95% of the battle right there. And click. And there's very, very little tolerance once it's in place. I can't shrink it 1/10 of a millimeter. So now that I've got the 3D CAD finished, let me walk you through it. And then, in order to make the first part of the shroud, the actual hood part, I drew this little sketch here on the X-plane. And then, in a really cool feature of Fusion, I simply rotated that shape around the edge and joined it to the main body of the shell. And that's down here. That's called a revolve command, which is so cool. You just do that, and then it automatically revolves it around for you. Then a little more housekeeping. And I created an offset plane from the base of the hood to the top, the very farthest edge of the lens. And I drew 2 circles, one for the inner part of the shell and one for the outer part of the shell. And I drew another set of lines connecting that. And then I just did another revolve command, and that built me my outside shell. It's actually straight. It doesn't have an angle, which is the same as the one that Patrick gave me. And then I applied the fillet command to round everything over so there's no sharp edges. You can see everything's got a nice rounded shape where possible. Sometimes Fusion is weird and you select something to give a rounded shape and it refuses. I think that's a shortcoming in Fusion and they should really work on that. It's not my problem if the internal representation of a shape as Fusion understands it doesn't want to put a smooth corner on it. Anyway, so this is where we are. So let's print this out and see how she looks. Okay, here we are, folks. 12.5 hours later. Print is finished. I did a little trimming with the X-Acto knife just to get everything nice and clean and smooth. And Click. Look at that. It's beautiful. It's actually pretty strong too. I can squeeze it like this. There's no chance of it cracking. It's got a lot of give. Now, one thing you will see is there's just a tiny amount of looseness in the joint, and that's just down to the tolerances here of what the, if I missed making something by 0.1 or 0.2 of a millimeter when I did the layout. But this will do Patrick for a while until he breaks it, and then I'll print him a new one. And I may just tweak the tightness of the clip action here, the bayonet action, and we're done. So I'm going to put this design up on Thingiverse for other people to download. I'll put as many keywords in there so they can search for Nikon telephoto lens. I'll put the actual model number of this lens in the description. It may fit other Nikon lenses or other, perhaps it's an industry standard. And then people can have it and keep the sun out of their pictures. Oh, I also forgot to show that it works in storage mode also. So we just flip it around, put it on, get it lined up, and click. So nice and compact, and that's actually quite tight in this orientation. So that's good. Okay, signing off. Hey, if you found this video interesting, please give it a thumbs up. And if you like my other content, I'd appreciate a subscribe. Take care and see you next time.